Okay, so today we're going to be solving exponential and logarithmic equations. This is going to be part one where we cover solving exponentials. Okay, so there's two basic properties for solving this. The first one is the one-to-one property and the inverse property. Okay, so the one-to-one property states when a to the x is equal to a to the y, only if x is equal to y. For example, if you have 2 equal to 2, and we'll just substitute x for x and 4 for y, then it simply just means that x is equal to 4 due to the values of a having the same bases. So x is just equal to 4 because of the same bases. The same concept goes for if you were to have a natural log, for example, to the power of to x and equal to the natural log power to, let's say, 3, then the bases are the same of it being natural log, so then again x is just equal to 3. Okay, so that's the first one, which is the one-to-one property. Now for the inverse property, okay, so let's look at this one first. What this is basically saying is log to the a is equal to a to the x, which is equal to x. It states that log base a composed to a to the x is equal to x because the two bases are the same and we are composing inverse functions. For example, let's do log, okay, we'll do this one over here. Log to the 4th, let's take 1 to the 16. Okay, so, well, first off, this is not in the inverse function form, so we're going to have to convert this to equal the function, the property. So what we would have to do is get two bases that are the same as a into a. So let's take log to the 4th. And since we have to get the same base, what number is equal to 4? Well, it's obviously 4, so we'll have to need 4 and then a negative 2, and the property is complete. Therefore, x is negative 2. Okay, now why did I do this? Okay, so since it wasn't originally in its inverse function, we had to take it to form its inverse function, which is try to get the same bases, a equal to a, which is shown right here. Now, negative 2 came from, well, where did I get the negative 2 from? The negative 2, since you had to find the base that would equal to this base, you had to find what times what will equal this. So 4 times negative 2 is equal to 16. It has to be negative because 16 is under the fraction, so it's just negative 2 because the 16 is under the fraction. This is basically equivalent to this. Okay, so for the example of this one, it's basically the same concept in reverse because the inside function is a log and the outside one is an exponent. For example, let's just do a quick example for this one. If you have 5 log 5 to the square root of 2, it just simply equals the square root of 2. Because the function is complete, we have bases that are the same. X is square root of 2, therefore the answer is square root of 2, because this completes the property and cancels out. Okay, now let's just do a quick example using the one-to-one property and the inverse property. Okay, so for the one-to-one property, alright, so let's take 2 x equal to 32. Now what we have to do here is we have to isolate x. So the first step to the one property, have the same bases. A to the x is equal to a to the y. Because of the formula, a to the x is equal to a to the y. So now, so that means we have to convert this 32 into 2. 2 to the x is equal to 2 to what? To what exponent can this 2 result to equal 32? So we've completed the first part of it, which is get the same bases. So what times what times what times what times what equals 32? So let's see. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. 1, 2, 3, 4, 5. 5. So it's to the 5th. Therefore, we have completed the one-to-one property, and x is equal to 5. Alright, one more example. This time we're going to use the inverse function. Okay, so inverse function. We're going to use the inverse. We're going to apply the inverse to solving a problem. So let's take, for example, alright, we're going to take 2 to the x equal to 42. Okay, so the first step to solving, our ultimate goal into solving this is we have to isolate x so we can get a solution. Alright, so what we'd have to do first, divide by 3 to cancel it, divide by 3. 2 to the x is equal to 14. This is where we're at so far. So we divided 3, and now we have got 14 from 42 dividing into 3. Now this is where we have to apply the inverse property. So remember the inverse property, we had to apply the same log bases. So let's use log base of 2, because log base of 2 will equal the property base of 2. So to the x equal to log 2 to the 14th. What you do on one side, you have to do to the other, exactly like we did it here. Divide by 3, we have to do it to the other side. So this is where we're applying our inverse function. Okay, so as stated earlier, when the log base of a is equal to the a, then it just equals the exponent. So we have x, now that we've completed the inverse property, is equal to log 2 to the 14th. Now we are almost done. Now we have to do one quick thing. We have to change the base. We have to change the base. So when you have something like this, to change a base formula for this is basically log to the a x is equal to the natural log of x over the natural log of a. Now to get our complete answer, we have to change the base. So this log 2 to the 14th will basically equal, here's our property, log, let's see this over here, a is 2, and then x is 14. So our x is 14, our a is 2, so that'll just equal the natural log of 14 over the natural log of 2. And this is our final answer, because we have now isolated x, natural log 14 over natural log of 2. And you could plug this into the calculator and you would approximately get 3.81, but for the sake of this lesson, this is our final answer.